Okay, hi everybody. Welcome to the third or fourth lesson of the C++ classes, May 31st. Um, Today we'll be going over, of course, the homework from last time. We'll do at the end, but we're going over some Boolean stuff that we found was extremely important carrying over from last class. And then we're gonna go into some loops. So we'll start off with doing while loops, then we're gonna do while loops, and then uh, for loops, and then at the end we're gonna go over some basic parts of an array. So if everyone's ready, you guys can just wrapple up and everything's set. We'll go ahead and start. So once again with booleans, it's a type of variable that can hold two values, either true or false. And they're extremely similar to other types of variables. Of course, you can define them, you know, on each on a line. Declare them. Bool B, bool C, or of course you can do all of them on the same line. Bool A, B, C. Again, I commented out, otherwise the processor, the compiler would throw an error. And then of course you can do both of them on the same line. You can do bool A is equal to true. Of course, defining all their values, etc., etc. So what we failed to mention is that some of the stuff that you can set equivalent to each other. So, for example, if you could create like bool C, we already have a bool C, right? We could just set C equal to just not the value of, let's say, 5 is less than 7. And then, of course, that's obviously going to be false. So if you're going to output this value, then we're going to get a value of 0. The right side. There we go. So that's the part we just made to mention, set it equal to a variable and go on. It should be fairly similar from last week's uh, Boolean uh, arithmetic and etc. So now we're going to the main topic for today, and that's going to be loops. So loops are extremely useful, and they're used to repeat blocks of code a certain number of times or even forever. And all loops utilize some sort of statement to determine whether the set code should be run or not. So let's start off with the easiest type of loop. That's called a while loop. So the syntax for a while loop is pretty simple. Go ahead and put it right here. It's just while condition, right? Right, then we just write code, and that's it. That's the exact value of a while statement. So we can do with this example. So again, with the if else statements, the condition is the same thing. It has to be a boolean or some sort of something like that. So let's say we create an integer called n. We set that equal to 0, and then we ran a while statement. While n is equal to 0, we just output n is equal to 0. And if you run this program, because you're not changing the value of n throughout, we should just output this infinite times. So if you look on the right side, there we go. It's very mind-boggling. We'll go ahead and stop that, but you get the idea. It'll output this infinite times. We can use it multiple ways. For example, you can say n is less than or equal to, for example, 9. Then you can just say n plus plus, right? Then it'll only output this a set amount of times. So we'll see it outputs a couple of times. I'm going to put an n line statement right here. So output it 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So we can utilize these sort of while statements. And then when the condition is not met, it just stops outputting the while statement. So we can do it another way. Instead of doing n plus plus, we could just say while n is less than or equal to 9, then just n is equal to 10 on the first iteration. So that way, we'll only do it once. So that's a really good way to use a while loop. There's one more way I wanted to show how to use a while loop. That'd be using a break statement. So break statement essentially just stops the while loop on that instance of the iteration. So we can say while n is equal to 1, while n is equal to 1, and just output cout n is equal to 1, of course. And then right after, if you have n, if n is equal to, let's say, let's say while n is less than or equal to, for example, 10. What if n is equal to 7, right? Then you should go ahead and break the for loop. And then let's say every time you want n to increase, let's say n is equal to the value of n right there. If you go ahead and run this program, we'll see. Oh wait, I need to redefine n here. So you go ahead and run this program, we'll see that's equal to 0, 1, 2, 3, 4, 5, 6, and 7. But once it reached the 7 one, so it goes and outputs 7. But if it reaches 7, it goes and stops in the entire while loop, and it goes on to the next value. So since you guys know how to use a little bit of while loops and how to use break statements and that stuff, we'll go ahead and give you guys a task. And that task is going to be, you're going to use while loops to output all the numbers less than 100. It's a pretty simple problem, so we'll solve it in 4 minutes. And of course, if you have any questions, go ahead and ask it in the questions voice channel, the questions text channel. Okay, so so I believe it's been enough time for all of us to have solved this problem. Let's go ahead and solve it together. So we're gonna output all the numbers less than 100. So we'll have a while loop. Actually, so we're definitely gonna have to have a while loop. Let's set an integer called number. Let's just set equal to num. Set it equal to 0, right? And then we'll do while num is less than 100. That's less than 100. We'll just go ahead and output the value of num, and then each time I'm just gonna add 1 to the value of num. So if you go ahead and run this program, the right side will see all the numbers less than 100 starting from 0. Of course, you can start from a smaller number, you can start from a bigger number, but we just assumed in this instance that we'd be starting from there, from 0. Okay, so in addition, sort of a variation on the sort of a variation on the while loop is what's often referred to as a do while loop. So do while loop is extremely similar. Um, its syntax goes something like this. Oops. Its syntax goes something like this. So it goes right here. So it goes do, and then it has some code right here, and then while this condition, example, while this condition exists, right? Sorry, just like that. Just sorry, the semicolon. Yeah, just do while condition. So we can use this in a variety of different ways. We can say do, let's say 8 plus 9 while 7 is less than 8, right? And then we can just output this. Output this an infinite number of times. So I'll go ahead and just do this. We'll just keep printing out 17. You just more strategically, you can have it, for example, output a number. Like, for example, we can say cout, we'll create another integer, for example, int j, set that equal to less than 98. We can just do, we can cout j minus 2 every single time. And then we can do j is equal to j minus 2. I'll set this equal to j, so we'll do the minus 2 eventually. And we're going to do while, for example, j is greater than 50. So we'll output all the even numbers greater than 50, starting from 98. We'll go 98, 96, 94, all the way down to 52. So now that we know how to use a do while loop, it's very similar to a while loop. We'll do a sort of a variation on the original problem we just solved, where that was print all the numbers from 1 to 100. We'll do the same thing, except we'll output all the numbers from 100 down to 0. And again, we'll give you guys 4 minutes. Okay, so um, it seems like that would have been enough time for you guys to do it. So we'll go ahead and solve it. So again, we'll get an integer. We'll call it num a because I've used int num a couple of times. We'll set that equal. So we're outputting all the numbers from 100 to 1, right? Set num a equal to 100. And we'll just do do right here. See out num a, right? And then we'll just do subtract 1 from num a. And then while num a, oops, wrong type of brackets. While num a is greater than 0. And if you go ahead and run this, we're going to see all the numbers from 100. Oh, the ones on the end of that line. Okay. There we go. So if you run this, we'll see. Oh, it's all down here. Yeah, we'll see all the numbers from 100 all the way down to 0. So as you can see, sometimes this is kind of tedious. We have to check the conditions, and maybe if the conditions, like for example, were greater than 1, then we wouldn't get the last value. So sometimes these sort of conditions get sort of tedious. And that's why I believe the best type of loop, in my opinion, is a for loop. So a for loop allows you to do essentially what a while loop allows you to do, except for a set amount of time. So for loops are a little more complicated. The syntax might throw a couple of us off, but it's not really that hard. So we'll go on with the for loop, and its normal syntax would be for a condition. Sorry, my bad. You have an integer a, like a how do I do it? So there's a variable initializer, right? A condition, and then an action, and then of course code. So probably the most common type of for loop you'll see is just a simple sort of an I loop, will be called for. Get an integer I, set it equal to 0, and then the condition will be while I is less than 10, the action will be I++, and then we'll just output verify. And let's break this down. Comment some of this stuff out first. If you go ahead and run this, on the right side we'll see it outputs the values from 0 to 9. So let's take a minute and look at exactly how this for loop was able to achieve that. So the for loop first went in and it created an integer called I that you can't use outside. For example, if I wanted to create, let's say I put cout I right here, it wouldn't work, or at least throw some sort of an error. Yeah, it'll be like there's undeclared int for I. So the int I only exists within the frame of this for loop. It can be used multiple times. We can have another for int I loop. I is less than like 20, and then you just put I++, and output the value of I, and it won't throw a problem at all because the I loop is only defined within that for loop. Oops. Oh, that's because I didn't define this. Yeah, so it doesn't throw a problem at all, right? It goes 0, 1, 2, 3, 9, and then 0 all the way up to 19. So that I loop only, the integer I only exists right here. And the for loop then says, okay, when I is less than 10, I'm going to go ahead and output, do this piece of code. And then every time, and then after each iteration of the code, once I reach the end of this semicolon, or in the last semicolon in the for loop, I'm going to go and add 1 to I every time I go through it. So the next time it'll be like, oh, I is equal to 1. Oh, I is less than 10. I'm like, yeah, okay. Do this part, and it's going to add 1. And do 2, etc., etc., etc. When it gets to 9, it's going to be like, okay, we'll do it. And then it adds 1, so now it's up 10. And when it gets to this part right here, it'll be like, is 10 less than 10? And it'll be like, nope, definitely not. And I'll be like, okay, now it looks like we're done with this for loop. I'll just stop exceeding the part of for loop and go right here. So I can put it right here. End of the first for loop, right? If we go ahead and run this, we'll see end of the first for loop right after 9, and then go on to the next for loop. Now, of course, with all parts, we can always change the variable initializer. We can, have a different name with the variable in j, as long as everything else in here is j. Okay. and then you can set it to initial like a different initial value. For example, if you wanted to count down while j is greater than, for example, 0, and then you do j minus minus, you can always change the condition for which the code has to run. Um, you can change what the value is. So for example, instead of doing j minus minus, you can just do j plus plus. Of course, this would go on for an infinite amount of time because it'll always be greater than 0. We'll just see a bunch of 0, 1, 2, 3, 4, continuing forever. But, or, instead, let's say you want it to stay the same, you can just do j, so we'll do j minus 2, right? And I'll do every even number because they're subtracting 2, and I'll output j. So that's the basic gist of a for loop. You can do nested for loops, which I think is the most important part for loops, especially when you get onto arrays, which we'll go into a second. But essentially, nested for loops, you have to keep track in one mind. Is that if you have an I right here, the nested for loop cannot also have an I. Then the computer gets really confused. It's like, which I is which? So we can define an I equals 0, I is less than, let's say, 10, plus plus, and you just put count I. The computer will be extremely confused as to what we were trying to do. So if you can copy paste correctly, it would output like something really, really bizarre. So, of course you want to have different values for each thing. So in this one, we'll just see a bunch of, we'll see like 10 zeros, 10 ones, 10 twos, 10 threes, all the way down and forth. Of course, you can always manipulate it, to make it more useful. So now that we have a little bit understanding for loops, we're going to write code that outputs all even numbers, as we just sort of did, all even numbers less than 1,000. Right here. Alright, it's supposed to say 1,000. Right, well, I'll give you guys just a bit of a harder problem, so I'll give you guys like 5 minutes. Okay, so I think it's been 5-ish minutes, so that didn't seem like a very hard problem for you guys. A lot of you guys posted. Oops, I was talking and my mic was muted. Regardless, that didn't seem like a very hard problem, so a lot of you guys went ahead and posted in answers. So we'll go ahead and solve it. We'll just create an integer. We'll call it number. So I don't think maybe set number 4. We'll go ahead and start at a value from 2, right? Let's do a for loop. Actually, since we're doing it in a for loop, we can just use this. So we can just do int I is equal to 2, right? I is less than or equal to 1,000, and then each time I just plus equals 2. So we can put that in. All you have to do is just output the value of I, and that's it. So I'll go ahead and comment this out. You go ahead and run this program right here. I'll go output all the even numbers. These are all even numbers. You scroll down. These are all even numbers, continuing on all the way up to 1,000. So I think that was pretty easy. It was a pretty easy explanation. I saw some of you guys using dual while loops. That's just valid explanation. We just wanted to test out, using for loops. Okay, so now I'm going to talk about forever loops. We experimented them earlier, that the condition is essentially never met. So we can just do like one example would be just a while loop, just while true, just output, high. Go ahead and run this program right here. Let's print out a bunch of highs. Or, you can just output while 1. Essentially, if a thing is never met, it'll be treated as like a forever loop. So that can be done the same way, a do count forever, and then just while, just while 1. That would work. So of course, we'll never stop doing the highs. I'll just go ahead and comment this out. And essentially, it'll never leave the loop either. We'll just keep printing out forever. And then the last version would be just a for loop. But we already experimented with that. We can have a thing, let's say, like j continually increases from a starting value that is greater than the condition, and the condition is like if this j goes beneath a certain value. Or you can just do just 2 semicolons, and just output, output, like let's say that. You comment this out as well. Go ahead and run this. Oops, forgot a semicolon. I'll just keep printing out a bunch of highs. Okay, so now that we have the gist of loops, for loops, forever loops, let's go on and do some more complex stuff that you can especially utilize with loops, which be really useful for a lot of you guys going into the competitive side. You want to try to pursue some US ACO, some programming competitions, or maybe just like for fun. But these are called arrays. So arrays are used to store stuff. You might probably already know. Arrays can be used to store stuff. But they're all stored in one sort of variable, and they have separate identifiers. So let's say if you wanted to store 10 numbers, let's say the birth, let's say the day of the week of which all of your 10 best friends were born on. Instead of creating a day, like a new string, like string day 1, saying that equal to like Sunday, etc. You can all just do it within a sort of array. Its syntax is pretty simple. It goes with int, and then just the name of your array. So I'll just call it ARR, and then the number of elements in that. So for example, if I had 10 friends, I'll just put 10. For in this example, I'll just use the ages of my 10 best friends. So int array 10, and then so in this instance, array index 0 would be the first element in the array, and then array 1 1 would be the second element, array 2 would be the third element, all the way up to array 9. Please note, arrays always start from 0, and they end 1 before the size of the array. So always keep that in mind, they're always like 1 below. It's sort of tricky at first, but you'll get used to it. And if you want to go ahead and do it in the same line, just just do curly brackets, and then each one of the numbers separated by comma. So I can do like 3, 7, 19, 3, 7, 19, 2000, something like that. I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So for example, if I wanted to output the first element, which would be 3, let's run array 0, the location in 2 brackets, output it in an end line. You go ahead and run this program. We'll get end of the first. Okay, yeah, we put on 3. If I understand, let's say my fifth friend, so it's 1, 2, 3, 4, 5. That would be 1 minus that, so that'd be array 4. Note the fifth friend is 65. Output that, we'll get a value of 65. And then of course you can individually set each element to its value. For example, if you didn't have this right here, then we could just go out and say like array of index 0 is equal to 9, array of index 2, array of index, let's just go with 1, is equal to, let's say, 98. If we went ahead and run this and then we output them later, I'll put it later, let's say 9, and then if you output it the first index, be 98. But please note, if you don't have a value like set, for example, if you haven't defined array 7, you'll output a really weird or big number, or maybe even 0. I'll set it equal to 0. Okay. You can also do multi-dimensional arrays, which are, you can just, let's say, like int array, right? Int 2D array. You can just have 2 parameters, 89 and then 98. And please note, it goes columns and then rows on this sort of notation. And then you can have 3D arrays, 4D arrays, but those take up a lot of memory, so also be careful with that. For now, we'll only stick to 1D arrays, but arrays can work with any type of data type. You can have char arrays, or let's say char values like char, and you can have size. You can have string arrays, size 98. You can have bool arrays. I don't think you can have string arrays. Never mind. You can have bool arrays. You can have double arrays. You can have float arrays. Essentially, the whole lot of them. So begin initializing an array can be hard with large arrays. So this is where the loops part also comes in. So let's take, for instance, we wanted to create 1,000 array that was 1,000 things big, right? So let's say array 1,000, right? And let's say I wanted to store all the values of 1,000 equal to exactly 45. So you can have, let's say, the size of the array, right? And size is equal to 1,000. So now using a for loop, just do for and I is equal to 0 because that's the first index, and I is also 1,000. Since it's an integer, it'll end at 999, which would be the last index. Then I plus plus, and you get set each part of the array equal to 45. And of course, if it's defined before, I'll just redefine it to 45, similar to integers. And we're going to go ahead and output all of this. Now taking the same for loop. And we'll just get 1,045. So instead of going through the curly bracket way that I talked about earlier, you can just do it through a for loop, which is why I believe for loops are the most important part of any C++. So this seems like 1,000. I think so. Yeah, that's 1,000. You can do it with while loops as well. You can just do like while at, like, let's say int j is equal to 0. It's like a sort of a variation on for loop. You can say while j is less than size, you can go ahead and do array I is equal to, let's say, just say array I is equal to I, right? And then of course, sorry, not array I, array j, and then of course just have a j plus plus in here. And now if you run this part again, we'll see 1045s. Oops, it looks like I've used the variable j before, so let's just say k. So we'll get 1045s, and then we'll get 1,000, order numbers in a row. So that's a really cool way of using for loops of that. So now that you know a little bit about arrays and a little bit about for loops, let's go ahead and have a task where we set 1,000. Actually, 1,000 is a bit much. Let's go with 100 array of a size 100, where all the elements are equal to your favorite number. So array with size 100, all elements equal to your favorite number. And we'll solve it in 5 minutes. Okay. So it looks like a lot of you guys got solutions to it. Go ahead and start it. So we'll create an integer. We'll create an array of. Actually, I'll create mine in rules. Just a sort of challenge. It won't be that much. And then let's find a good name. Let's say fave, and let's say 100, right? And then just do 4 int I is equal to 0, I is less than 100 plus set fave 0. I mean, sorry, fave I equal to, let's say, 3.14. Let's say that's my favorite number. And then we'll go ahead, the same thing, we'll output the value of each one of these. We'll see a bunch of 3.14s. Go ahead and run it on the right side. Yeah, we'll see a bunch of 3.14s. Okay, so now that we know how to do some of this stuff, let's think about an instance where a person wants to input, let's say, 10 unique numbers that they want to store for a future date. For example, let's say they're creating, let's see, a security number, and it has to be in a form of array. So that way they like sort of sort the array, or they jumble up the array in a random fashion, and then they have to rearrange the numbers when they're like sort of creating a login password. So let's only talk about, let's say, inputting, let's say, their password, or like when they're creating their password essentially. So what you can do is that we can essentially have arrays. Let's call this one just password, abbreviated. Let's say there's 10 digits in their password, right? And let's have an integer x. And then let's have a for loop, right? Int I is equal to 0. I is less than 10 because there's 10 digits in the password. I plus plus. And then we'll just say we'll send into the x value each time, right? And then the array of value of each part of the x. So remember, when you're inputting into an x, it continually redefines the value of x, right? Let's say array I equal to x, and then later on we can just output your password is that value, right? So we're going to clear this out. Going to run this. It's just going to wait for us to input 10 numbers. So let's say 9. Oops, what? Is the program running? Oh, I think it's not running, right? Oh, okay. The computer was still running. It's going through all the stuff. Okay. I think it's asking me for anything first. Okay, now it works. 9, 8. Let's say 6, and then let's say go back to 9, 6, 7, 2, 8, 4, and 5. And then my password, as says, is 9865 in that fashion. And then if you wanted to do something, you could develop an algorithm. Let's say flip the orders on the numbers multiple times. Like you could say array 2 is equal to, you create a sort of a duplicate value of the array. Like array 1, like the position 1 is equal to position 5, 5 is equal to 7, 7 is equal to 3. Sort of jumble up the array and then have the person essentially reorder the numbers. That's a really good way of using arrays and for loops in sort of a cohesion to do something that's like as simple as, making a password. So for today, we've essentially gone over some basic parts of booleans. We've gone over types of loops. We've gone over some while loops, some for loops, and then using arrays, and then arrays in combination with for loops. Now I'm going to go on to some of the homework problems that you guys had done from last time. I'll leave them up on the board because we didn't get too many responses, so I'll let you guys solve them, maybe like 5 or 6 minutes. Maybe you guys like go over your code a little bit, and then I'll go ahead and solve them for you guys. Here's the first problem. Go ahead and look through it. If you have a general idea, you can write some pseudocode or maybe write all the code. Just go through it from the last time's class. I'll solve it in about 2 or 3 minutes. Okay, so I feel like everyone had some time to at least look at the problem, maybe come up with a pseudocode sort of solution. So it says write code that can serve as an automated cashier at a shop by asking customers what items they want and with how many. It should be done with if-else statements, since out, CNC out, and strings. The code should output a list of items, have the user choose which ones in amount, and the code should output more information with the item, i.e. the price. So let's go out and start off with hello, welcome to our store. What would you like to buy? And then put in this off the line. We'll output we have let's say tomatoes. Let's say something easy. Let's make it pizza and put a number right next to it. Pizza, tacos, burgers. Let's say 3, and fish. Let's say 4. You know, of course, they're all very variable. What would you like to buy? Right? And then so let's say if they press 1, right? 7 int x. Then I'll ask them how many would you like to buy? I'll go ahead and input them how many they wanted to buy, and then using the cost, let's say we'll have an int total cost. Actually, I'll have a double. Right, 0 total cost plus equals num to buy times the number of times the cost. Let's say a cost for pizza is, let's say, $7.43. We're going to go ahead and copy this if statement a couple of times. You know, if and then if x equals to 2, 3, 4. You know, let's just say all the prices are $7.43. And then at the end, just output them total cost, and then thank you for shopping here. And then I put the end line. So oops, what happened? Oh, looks like I didn't press the semicolon correctly. Oh, redefinition of int x. Okay. Also we use the int x. J I K. Oh, there it is. When I run this, it says, what would you like to buy? Let's say I wanted to buy burgers. Let's see how many I wanted to buy. Let's say I wanted to buy 8 of them. Let's say $59.44, and thank you for shopping. So that's a pretty good example of how to use let's say if-else statements, some strings on how to create a sort of an automated cashier. I'll go ahead and put up the second problem right now. Go ahead and take a jab at it, write some pseudocode maybe, and then I'll solve it. Okay, so I hope that everyone's gotten, let's say, a little bit to look at these questions. These don't look like very hard questions. We'll go ahead and solve them. It says maximum of 4 inputted numbers. So we'll create 4 variables A, B, C, and D. We'll input all of them A, B, C, and D. And then let's do a couple of if statements. So we'll create an int max, right? And if we want the max to be as big as possible, we should create the base layer for it to be as small as possible, right? So let's say int max is equal to, let's say, negative 100. And I have an int min, it's equal to 100, right? So just go through, say if a is greater than the max, right? And set the max equal to a. And then else if b is greater than the max. Actually, else if statements would actually trip this up a little bit. For example, if a was 5 and then b was 7, but let's say it is already greater than the max, then just set that equal to the max. So I'll just do it in a bunch of if statements. If b is greater than the max, then you can just do max equal to b, and then if c is greater than the max, then max is equal to c, and then finally if d is greater than the max, max is equal to d, right? And then for finding the min, you do the same thing, copy paste all of this. If a is less than the min, then we just go ahead and output max and min. Oh, so it looks like we've already defined A, B, C, and D earlier. They're all in the bools, so I'll just scroll back up, comment that out. Oops, look, we've used C before as well. I comment that out. Okay, so the code's running. Okay, so now it's running. So let's say 3, and then 3 of them. And then, so it's going to ask us for 4 numbers. I didn't explicitly ask us, but you know. Let's say 8, and then let's say 78, let's say 67, and then 3. So the max, it gives us first the max, which is 78, and min, which is 73. So that's going to be it for today's class. If you have any more questions, go ahead and stick around. Ask them in the CPP lecture thing. A is 200 and B is 150. And want an output B for max, which is incorrect. Okay, so let's try that out. Let's go and run the program. Let's do some nice debugging right here. Good question, Pharaoh. What is going on with my REPL? So yeah, so let's do A is 200, and then B is 150, and then C, let's say 67, and then 3. Nope, our code actually doesn't output 200 or 150. Here's why. The second after we define max is equal to A, then it compares that equal to the max. It doesn't compare the initial max equal to negative 100. So it continually redefines max only if it's greater than the current max, and then continually checks it again. Okay, nice.